Hey everyone, Dave here. We had a bit of an issue with tonight's show. It's actually already happened. We streamed and went live a couple of hours ago and it all went swimmingly, but after the show we had an automated copyright claim based on a little bit of BBC material that was in there. Now I'm absolutely convinced what we did was genuine fair use. However, the video has been blocked in all countries forever, so it was just taken off basically. So what I'm doing is I'm restreaming the whole thing. So unfortunately we are missing out on the live chat on the YouTube channel. You won't be able to see that box on the right there. You will still see the comments as we put them up during the show on the video screen, but you won't actually see the box there. But anyway, what I'm going to do now is play the recorded version of the streamed video for you. So with that, here you go. Hello everyone. Welcome along to Space Dave Live, episode number 11. I am Dave, and with me tonight we have, I'm just making sure that, is our audio actually going out there? I hope it's going. Someone tell me if my audio's going. I'm not hearing anything in my headphones. I hope everything's going all right. I'd hate to have another technical issue tonight. We've been so good with them lately. Anyway, look, tonight with us we have a record-breaking crowd. Check this out. Okay, isn't that awesome? We've got heaps of people with us here tonight, so thank you all for coming along, everyone. And over in the background there we have Floyd helping us out with social media and the technical stuff and all that sort of thing. So before we get started, let's just have a quick check-in with our chat situation. So here we go. Now we've been tweaking this a little bit each week, and I think we're getting a little bit better with it as we go along. So you see I've swapped a couple of things around here, but hi guys, hi John, Fletcher, Jeffrey and John again. So hopefully if you're not hearing me properly, someone will have said so by now. All good on Facebook. Thanks Rox and Angeline, welcome along. Thank you very much guys. So it looks like we are indeed all in business. So shall we start by having a quick look at our program, shall we, and see what we've got in store tonight. So after we've done the introduction and competition and stuff, we've got a fair bit of news to get through tonight. We are going to spend a bit of time talking about that Starlink mission. You remember we were talking about that last week. It's the SpaceX mission that was delayed a little bit and launched just a couple of days after our last show. So there's a few things that have come out of that we will want to talk about. I want to mention Matariki tonight. We'll talk more about that as it gets closer to the time, and we've got a list of other stuff to get through. In the night sky tonight, we'll actually probably talk about Matariki a little bit there and mention the Venus-Moon conjunction coming up. I'll get to the flat earth thing later if we get time to talk about that. It's not really much, it's just a little bit of a mention of a possibility there. So that's kind of what we've got in store for tonight. So shall we start off with the competition? That's what we like to start with. So, look, as I keep saying on the show here, this is a really, really busy time here at the Space Centre. It's mental, actually. We've got schools coming in every single day. When the schools aren't open, then we're open to the public, so it's 7 days a week. Today, of course, the teachers were on strike, so we opened and we had a busy old day, so thanks to everyone who came in today. So I'm sort of thinking, to be honest, in the weeks coming up, I'm a little bit nervous about being able to keep the show going every single week because I'm just having almost no time to prepare for it. So I'm trying to think of ways that we can do the show with me doing even more winging it than I normally do, which is a lot. So one of the things I'm thinking that I would really like to do is have a lot more spontaneous parts of it at least. So I'm sort of throwing the idea out there for you guys to just throw in ideas for things to talk about. So, for example, well, tonight the competition is basically going to be you write topic, colon, and then what you would like to talk about. And so let's assume that we're going to run out of things to talk about tonight. I don't think we will. I think we've got a good list of stuff here. But let's say we're going to run out of stuff and there's just something random that you want to talk about, anything at all to do with space. Now, part of the competition here is to see how well you guys follow instructions, because we're really keen on following instructions here. So you will write topic, colon, space, and the thing that you want to talk about. And that just helps us when we're looking through the chat comments so that we know which ones are competition entries. It means we can just sort of squiz through. So we've got more people coming in. Hi, Harry. Another John, 1948. Space fan from Christchurch. First visit. Hope you enjoy it, John. Thanks for joining in. Stephanie, hi. Jeanette, Tristan. Tristan, your prize is in the mail, by the way. I'm not quite sure when it's going to be there, but it should be there within a day or two. Let me know if it's not. So that's the competition, so get amongst that. So if any of you guys out there want to say something, you are more than welcome to say something anytime. Did someone want to contribute something already?
Yeah, I have an idea for the competition.
Oh, you do? Okay, what's your idea?
How the solar system system was formed.
How the solar system was formed. Okay, look, I tell you what, thanks for that. If we get a chance tonight, if I run out of stuff, that's a great one, actually. Well, I love that. So, yeah, remind me if we get stuck short of things to talk about. But there are a few things that we do need to talk about tonight. So, we need to take care of our housekeeping stuff. A couple of other quick things that we just need to talk about first. Actually, not a lot, but I do quickly want to talk about our Patreon page again. So I'll probably do just a quick mention of this each week. So our Patreon is where you go and sign up and give us money. So as I keep saying, it does cost us money to do the show each week, and we really appreciate all your contributions there. Now, a couple of things I want to point out here. If you, I've mentioned this previously, but if you join up as a patron, well, one of the things that I'm keen to do is do some sort of behind the scenes stuff. So talk a little bit about what is going on behind the scenes here. One of the things is to give you a little bit of early access. So we talked about the show notes. There's a couple of things I'm trying to talk about here. So the show notes, first of all, if you have a look in the description, now this should be available on both YouTube and Facebook tonight. I finally got around to putting a link to the show notes. So as I talk through the show, I'll mention links in the show notes. But if you're a patron, you actually get access to them earlier. So during the week, as I'm getting the show ready, you can go on, and if you're a patron, you can just click on these links here and you will be able to get in early, so you know what we're going to be talking about, you know what the links are, and you can formulate lots of very clever sounding comments that you can contribute throughout the show. So that's one of the things there, and since last week we do have a few new patrons that we need to thank. So welcome on board Anthony Miller, Alan and Wendy Tolland, who are here with us tonight as every night, Troy Mitchie and Nat Lee, who is also with us here tonight. How about you guys give us a wave out? Yeah, thank you very much for coming on board, you guys. Now, actually, everyone that you see in the audience there has contributed in some way. So I'm really stoked that you guys all showed up for the show tonight. So thanks for coming along. Is that all the housekeeping stuff we needed to get through? Show notes, Patreon, yeah, I think that's about it. And I think it is time to start talking about some space news, because that's what we're all about. I think probably the big thing in space news this week, and the one that we will spend the most time on, is the Starlink one. So you remember this picture. This is SpaceX's mission to send 60 satellites, and that's what you're looking at there. This is all the satellites stacked together in the fairing, in the rocket before it lifted off. These are satellites that they're for internet access, internet service providing satellites. So hang on a sec, let me just have a quick look at my note here. Okay, thanks for that one, Floyd. Anyway, so this was launched, was it last Friday? I'm pretty sure it was last Friday. Anyway, so let's just have a quick look at the launch first. Now, there's a few things about the launch that I want to talk about. In itself, it's not a particularly unusual launch. We'll just have a little bit of sound going with that. It's a nighttime launch, so that does make it a little bit different. And so I want to just talk about some of the things that happen during the launch. Then we will get back to talk about the actual Starlink satellites and mission themselves. So it's pretty nice looking nighttime launch, evening launch, as you can see it going up there. See the reflection in the water down there. The timeline along the bottom. Keep an eye on the timeline, because we are skipping forward here. I've edited it a fair bit. So we're still just at T plus 20 seconds here, but then we skip forward a little bit, and I'm probably going to want to stop it a couple of times and just talk briefly about what's happening. So this is just before the stage separation, so we're T plus 239 here. So the one on the right, that's the bottom of the second stage, which will carry on to orbit. The one on the left is the one that the booster that falls back towards the Earth, and there you go, that's stage separation. So that's a big milestone. There on the left, that's a view facing back towards the Earth. The second stage is carrying on to orbit. So let's just watch this for a sec. On the right there now, sorry, hang on a sec. On the right, you are now looking at what we saw before, that picture of the satellites in the fairing, and that's going to be deployed into orbit shortly. And on the left, you're actually looking back towards the Earth. You can actually see some of the lights there. You see up sort of the top left there? That's the lights looking back towards Florida. So the fairing just deployed or went away there. So that's the second stage engine burning on the right. Then on the left,
Redmond is happy too.
we should be seeing the next burn coming up.
See the camera on the first stage on the left-hand side of your screen right now. It's dark,
Stage
but
one,
in a few
ATS
minutes, those
safety.
Merlin engines at the bottom of that first stage will light up.
Right, here we go.
And there they go.
So that's the entry burn. Remember that?
Start of the entry burn.
So this is the burn on the booster that you're seeing there. The rockets are burning, and that's the burn that just sort of slows it down so it starts coming back down towards the Earth. This one's actually going to land on the barge in the ocean. Unfortunately, the video from that feed did cut out, and we didn't actually see the entry burn from there and the landing.
And that's it. That is the end of the entry burn.
But we did
The next
see.
step for that first stage is going to be the landing burn.
Right, so the landing burn will be coming anytime soon, but we don't actually see it, unfortunately.
The landing burn has started as scheduled. We don't currently have video from that first stage, but stand by. We may
Vehicles
be
and
able
terminal
to get
guidance.
something from the drone ship.
So the next shot will be on the drone ship. That shows you where
It
they
sounds
are.
like we may have confirmation that the first stage has landed.
There you go. So that's the first stage back on the
That is a
drone
shot
ship.
From Of Course I Still Love You.
So I'll just stop it there. So just a couple of things here. That booster there that has come back and landed on the drone ship, that's the third time that that particular booster has landed. So that's pretty good news, eh? So we're starting to get more into this era of actual reused, not just reusable. We're actually getting the boosters come back, being reused, and showing that we can keep it going. So that's good news. The next thing will be the actual deployment of the satellites in space. So
The first stage of the Falcon 9 rocket for its third landing.
I think that will be the next shot. So hang on, let me just pause it there again. So see where it is now. So we've jumped forward. We're now T plus just over an hour. So that we've waited quite a long time here. And see, it's actually heading towards the south of New Zealand there. So this is stage 2 with the satellites that are getting ready to deploy. And they deployed in a bit of an unusual way, actually. So normally with satellites, they would, if you've got a whole bunch of satellites, they deploy them one at a time. But with this lot, they deployed the whole lot, all 60 of them, all together, and then it kind of did this sort of rotation thing, and they all just split up, and each satellite has got its own little propulsion system. It uses ion propulsion and finds its own orbit from there. So it's a little bit unusual. So let us cut back, and we will just have a look at that happen.
Constellation deploy confirmed.
There it goes
And we
there.
have confirmation
So that's the
of
whole
deploy.
stack of satellites
You can hear
all
this
heading
in
off
the
to be
background.
deployed.
This is an incredible moment for SpaceX. You can see those flat-packed Starlink satellites slowly gliding away from the top of the second stage. This is the high.
Okay, we'll stop it there. Now, we don't actually get to see them all split up from this view and do their thing, but we're going to get back to that in a minute. Right, so there's a couple of things I want to go back over here. So, first of all, let's go back to the actual launch. So, let me just make sure that I've got exactly what I want to talk about here. Okay, let's see. I'll tell you what. Let's have a look at a couple of these photos first of all. So I've managed to find a couple of photos online, well, a few beautiful photos actually. So one of the really nice things about these nighttime launch is you can get these lovely long exposure photographs of the whole launch. So this one was courtesy of Swashbuck on Instagram. So that's a lovely photo. You can see the whole thing there. You see the people watching the launch on that perfect viewing platform up there. So that shows you the first few minutes of the launch. If you look closely, you can see the stars there. So you can see how each of the stars is, it's a small trail. So in the few minutes that rocket has launched up there, that's how much the stars have moved. And I'm just looking at that and I'm thinking, less than 5 minutes, that's 2 to 3 minutes. I should have looked that up, but yeah, that would be somewhere between 2 and 3 minutes, I'm thinking, that exposure there. And so you can see how much the stars actually move in such a short period of time. So thanks, Swashbuck, for sharing that photo with us. Here's another one on Reddit from Reddit user AlexBrock57. Here's a similar one. It's a long exposure photograph. You will see in this one that the stars don't have trails on them, and that's because this one is actually a composite. So this guy had done that photo, he'd taken the long exposure photo, and then immediately afterwards just taken a quick photo to expose for the stars and put them on top of each other. So that was really clever. That's a beautiful photo there. Now I want to show you this other photo. I've got it over here. Just bear with me a sec. Let's have a look at this one. So this one is a really interesting one. So this was on Reddit as well from user Marcus Coat Photo. let's just click on that and full screen it. So there's a few things going on with this one. Another long exposure photo. Again, you can see the star trails up there. So it starts off with the launch. So you can see, excuse my squiggly lines, all the way up there. That's the first part of the launch. Now, look, if there's any rocket heads out there, people are really, really into this stuff and know all the details, tell me if I've got anything wrong here. So I think what we're seeing is the launch all the way up to about this point. That would be main engine cutoff. And then so you don't see anything for a short period there. Then this must be stage separation there. And you can actually see some of this gas coming out and floating around here. And you could actually see that. I should have mentioned it in the video we saw before. At stage separation, you see a bit of gas just sort of coming out and dispersing. That's where it gets a little bit more complicated. Now, I'm picking what we've got here is this line down here would actually be the second stage that is heading on towards orbit. So it looks like it's just this sort of big parabola that comes back down here again, but I don't think that's what's happening. That must be the second stage that is heading on eastwards and actually going around the Earth. That's what we saw before to deploy the satellite. The booster that's going to come back down to Earth must kind of go up here a little bit and then fall down. This bit would be the entry burn that we saw before. So that's the burn that it does that slows it down so that it falls down. Then it just falls all of this way. And the last little bit down there is the landing burn as it comes into land. That's the bit that we didn't get to see. And then it just lands on the drone ship just over the horizon down there somewhere. So what a great photo that shows you the whole thing all the way. So I'm pretty sure I have got everything right here. Does anyone want to disagree with me or point anything out? Oh, looks good. Okay, so I think we're happy with that one. That's an awesome photo. I really enjoyed watching that one. So that was that one. Now I've got one more thing that I want to show you here, and it is a short video. Same thing, part of the same launch. So let's just go and have a look at this. Now this was from Reddit user Mossberg 91. So it's a short video. It's actually sped up, but keep an eye on this bit over here. That is the rocket launching. Now watch this and be amazed. Check out what happens. Isn't that beautiful? Isn't that awesome? Spectacular stuff. I'm going to keep it on loop while I talk about it because I think it's just so cool. So what I'm going to do is I'm going to read out Mossberg 91's own explanation that he put on the Reddit thread where he posted this. He says, what you're seeing is stage separation where only half the rocket keeps heading towards orbit. You can see the other half drifting off towards the right. So watch it here. So you see that bit, see the bit drifting off to the right? Okay, so that's the stage separation there. As to why you are seeing it, the sun has just set, so it's dark where the viewer is and where the rocket launches from. So when it gets high enough and the separation phase happens, a bunch of chemicals drift into the atmosphere and freeze, creating little crystals. Then the light from the sunset illuminates them, creating the light show that you are seeing. So you often see effects kind of like this when you've got these evening launches. So the sun's not too far away over the horizon there and it's still lighting up all the stuff, but you get that beautiful night sky to see it against. So that's really spectacular. Now, if you are a little bit concerned about all the chemicals being dropped into the atmosphere, I'm not sure exactly what every single one of those chemicals will be, but now this is the Merlin engine which uses RP1. I've got to think about this, the rocket propellant one, which is actually, as I understand it, a pretty clean burning fuel. So it's rocket grade kerosene with liquid oxygen as the oxidizer, and my understanding is that leaves basically carbon dioxide and water, which is it's a pretty clean burning sort of thing. So I wouldn't be too stressed about the chemicals there. I don't think we've got anything to worry about with that one. So anyway, I thought that was really cool. I enjoyed that one. So anyway, that's the launch. But we're not done with this. I said that this would be the thing that we talk mostly about. We need to talk about what happened after that. Okay, because this can be a little bit of an issue. So let me see. I'm just going to show you a couple of, I'll tell you what, I'll show you a blog. Let me get this person's name right. It was Marco Langbrook. I hope I've pronounced that right. Who managed to catch some shots of what they're calling the train of satellites. So this is in Europe, of course. So the satellites have all deployed and then they're all starting to spread out and go into all of their orbits. Let me show you a video down here. So we'll explain about it a little bit in a sec, but look at this. Imagine seeing something like this in the night sky. Actually, I should full screen that, shouldn't I? Look at that. Imagine looking up and seeing that. Wow. So a couple of things about it. Now, my understanding is that this particular train that you're seeing here is less than 10 degrees wide and not as bright as it looks there. So you've got to remember that this is the camera's version of what we're seeing. Let's just go back to the start of that and just have another quick look at it. So in terms of how big and how bright this would actually be in the sky, if it's less than 10 degrees wide, so 10 degrees in the sky is roughly equal to your fist out at arm's length. So if you hold your fist out like that, and imagine looking up at the sky with your fist out like that, that's about 10 degrees wide. So this would be less than that at this stage at least. I've seen a couple of other photos where it's spread out to being sort of around about 20 to 30 degrees wide. But that's about how big it was when they were all together. As to how bright these are, as you saw it there, it's still quite bright, but the satellites haven't actually got into their finished orbit yet, which is higher, so they won't be as bright when they get to their final orbit. However, I'm in two minds about this, I really am. I think that's a spectacular sight, it's awesome, but do we want to see that every night? Do we want to see a whole sky covered in those things? These are 60 satellites. Elon Musk is planning on putting 12,000 of those satellites in our skies. 12,000 of them. Now that's just SpaceX. They're not the only company that's looking at doing this. This is starting to become a really popular thing. The point is that these satellites theoretically will be able to provide cheaper, faster internet coverage than our ground-based systems, and we talked about that last week, about why that is. So my concern is that there's going to be nothing holding companies back from just doing more and more and more of this and filling the whole sky with these satellites. Now have a look at this. The Starlink system actually has its own website now. This is separate from the SpaceX website. It's a pretty cool website. You can see all the stuff here. You can actually move it around a bit and see it all from different angles. Now, I don't know how well you can see that, but there's a lot of satellites there, but it's not 12,000. There's a lot more than that. It's going to be looking pretty busy up there, and this has created quite a stink, frankly. Just while we're here, let's just scroll down and have a little bit of a look down here, because this shows you the actual satellites. So each satellite has one solar panel that extends like that, and you can see that bit at the bottom. Now that's the bit that is facing down towards the Earth, and it's really shiny, so it reflects the sunlight a lot. So you imagine 12,000 of these things orbiting around the Earth. So while I'm always into having faster internet access, I'm not sure about the price that we're going to pay here. So a lot of astronomers have started pushing back against this. And look, let's just have a quick look at some of the tweets that are going around. I don't expect you to read all of this, but in short, what's happened is that some astronomers have come out and pointed out that this is actually quite serious for astronomy. If you're trying to do astronomical work, then let's just talk about that for a sec. So imagine that you've got your big telescope and you're pointing at a part of the sky and you're trying to collect astronomical data. Now, every once in a while, you will get something interfering. It could just be a cosmic ray, it could be a satellite or something going in front of it, and that will spoil at least part of that picture. And then you've got to take another one because you lose that data from there. So it's a setback. Now, this happens all the time. So it hasn't been a really big deal up until now, but if you're getting these satellites going through all the time, it is a big deal, and it's really going to set astronomy back. It's going to be quite a problem, potentially. So what's happening is everyone's arguing about exactly how bad this is going to be. So some of these astronomers are getting really upset about it. Elon Musk, I think, has been a bit surprised by some of the pushback here, and he's saying, relax, it's not that bad, it's all okay. He said, for an instance, they can't be seen at night. And this person has responded saying it's not true or reassuring. So because these satellites haven't actually got into their final orbit, we're not exactly sure how bright they're going to be. We don't really know for certain how bad this problem is going to be. But even if you can't really see them that easily with the naked eye, my best guess is that there's going to be a lot of them out there. You still will be able to see them, but for astronomers, it's for anyone who actually trying to do research and take proper astronomical pictures or gather data, it is actually going to be potentially a really serious problem. So we probably don't need to go through all of them. Now, so Elon has said down here, we'll make sure Starlink has no material effect on discoveries in astronomy. I can't see how he's going to do that. Even if you can't see them at all, they are still destroying data and getting in the way. Someone here has suggested that they could look at how reflective they are. So albedo, that word there, that means how reflective something is in space. And Elon Musk has said that he is taking that seriously, and he's talking to his team to see if there's something they can do about that. So that would be a good thing. Remember we talked last week about Elon Musk winning the Science Communication Prize? And I was kind of like a little bit, you know, is that a great decision? Because he can be a really good communicator, and then he can say stuff like this. ISS is extremely gigantic and has lights. Someone was comparing it to the ISS, and what Elon is saying is that, well, the ISS is different, it's so bright because it's got lights. Well, Elon, what? You send stuff to the ISS. You know better than that. The ISS does technically have some outside lights, but you can't see them from Earth. Anyone who's seen the space station go overhead, some of you guys would have seen the station go overhead, you know what it looks like, and you would have seen that when it goes into the Earth's shadow, it disappears completely. You can't see it anymore. So, sorry Elon, I mean, I don't know, that's a dumb thing to say, quite frankly. I don't like saying that, but it is. What was the last thing down here? There are already 4,900 satellites in orbit, which people notice 0% of the time. Not so. The people notice satellites all the time. When I go outside and do evening sessions with people, it's the satellites that people notice and pay attention to. They definitely do notice them. Starlink won't be seen by anyone unless looking carefully. Well, that may be. We don't actually know that yet. But having zero impact on advancements in astronomy, sorry, I'm not buying that. It's going to have some impact. The question is how much. So, and as for his comment about atmospheric attenuation is terrible, I guess what he's saying there is that we need to move telescopes into orbit because we can't see enough from the ground. Again, that's just nonsense. The vast majority of astronomical research is done from the ground and absolutely will be for the foreseeable future for many reasons. Space-based astronomy has a big place, but we're going to keep doing it on the ground. Most of the telescopes, most of the research is done on the ground. Anyway, I think that was important to talk about. We need to wrap that one up really, but sorry to go on about it, but the thing that concerns me is that this is another one of those things that's happening without people even knowing about it, without people even talking about it, and we're just not even aware that it's happening, and it's just happening bit by bit, and then suddenly our night skies are going to be spoiled. So as much as I love seeing some of these cool things in the sky, and people, when you see the threads about it online, almost all of the reaction, just generally speaking, has been, wow, that's spectacular, that's really amazing, doesn't that look cool? Yeah, you might have said that the first time you saw an aeroplane, but do you want to live next to an airport? Do you want to see nothing but planes in the sky? We've got to be careful about this stuff. We've got to be thinking about this and looking where it's all going in the future. Anyway, I need to move on, don't I? Sorry, yes, let's go out into the audience and we'll get a question out there. Yes?
All these private companies putting satellites up, can they do it with no permission from anyone? They can just do it?
What a great question. That is a really good question. That situation is changing. So it does depend a little bit on your jurisdiction, where you are launching from. So in most countries, when you launch something, you have to apply for a launch license. Even here in New Zealand, we have a New Zealand Space Agency now. You have to have a launch license to launch things into space. Now, things are changing and they are getting better. For example, in the past, you could just launch anything just about willy-nilly, and there wasn't really much tracking of space junk. Well, sorry, not much regulation, I guess, of space junk, even though we do track it. But these days, it's getting harder to do that, and companies are becoming more responsible, and there is more of an expectation that you will deorbit the things that you don't need, and you will have a plan for the sustainability in the future. So, look, companies like SpaceX did have to have permission to do this. They've been through the whole process. So yes, legally, they actually have permission for everything that they've done there. What we need to be doing is we need to be leaning on the governments to make them a little bit harder on them and tightening the restrictions and saying, well, I guess the point is that most of the regulations are around safety and space junk, not really about how much it's spoiling the night sky. That's not really a thing that's taken into consideration, and I think that's where the problem is. So when launch licenses are considered, we need to be talking about, have you considered the albedo of these things? How much is it going to upset astronomers and destroy the night? So yes, they do, it is regulated, but in my opinion, not enough. Okay, so that's that. What I should do is just check the chats and see how we're going here. Oh, look, we've got lots of stuff going on. Yikes, I'm not going to get through all of this, am I? Look, hi everyone. I'm not going to try and go through every single name here. I'm sorry, Dave, I'm afraid I can't do that. Nice one, Harry. Right, so, okay, I think I'm going to have to get back to this a little bit later on. I am reading all of these, I think I'm reading, actually, sorry, I am reading most of them, but I should quickly point out I have noticed that some of the comments aren't coming through on our feed here, and they're not coming through till later. So I don't know why that's happening. Apologies for that. Right, okay, so that's them. Lots of entries for the competition. Get Peter Beck. Thanks, Tristan. That would be a really good one. Mike, I haven't forgotten about your Parker Solar Probe thing. We will get to that. Hey, Sarah Jane, nice to see you here. Haven't we got a good audience tonight? They're nice people too. They're not just here to fill seats. Okay, look, there's some really good suggestions there. Thank you, guys. So we've got lots of stuff that we can talk about if we get stuck for things, haven't we? Awesome. Someone said Pandora's box. It's like the Pepsi sign all over again, isn't it? And you know what I thought about the Pepsi sign. I think I made my feelings about that pretty clear, didn't I? Yeah, so anyway, we need to keep an eye on it. But it's 7:30 already, so we need to talk about some other stuff. I want to show you a couple of video clips. Here, let's go over to our video player. These are a couple of clips that I recorded from one of the cameras that's outside the International Space Station pointing back down to the Earth. So this is the live streaming video, and that's New Zealand that you can see below there. You can see the South Island, and we're just heading towards the North Island there. So this is one of the 4 cameras that's mounted outside the International Space Station pointing back down towards the Earth. It's a beautiful view, isn't it? So this was on Saturday. You can see the Pacific Ocean out there. And then there's another one coming up that I recorded just today, actually. It was at 11 o'clock this morning. The next one is a different angle. This one is pointing straight back down towards the Earth. So that is actually New Zealand just below there. These are sped up, by the way. The first one was 5 times. This one is just double speed. So where is it? You can see, I think, below there. This is the South Island. That is Banks Peninsula at the top left there, just coming into view. So you can see Christchurch there, just down below the text there. So anyway, what I wanted to mention here was that we love these views. This is just spectacular stuff coming from NASA. So they've got 4 cameras mounted up on the space station pointing at the Earth, and they're pretty good quality. I mean, I think that's nice here that you can see New Zealand pretty clearly there. It's not the greatest, and a couple of their other cameras tend to not be as good quality as this. That is a really nice view. It's an unusually nice view from that live feed looking back down at New Zealand. So that's what New Zealand looked like earlier today, pretty clear over a large part of the country. Actually, I posted this on Facebook earlier today, and someone mentioned that that would have been a good view for Rocket Lab, because you can see Mahia Peninsula down there. So if they'd timed this with a Rocket Lab launch, that would have been something else, eh? That would be awesome. Anyway, the point of all of this is that I don't know how long these cameras are going to stay up there, possibly not forever. Technically, this is actually just an experimental system that they've got up there. And I've been hoping for quite a while that someone would get round to putting an even better camera up there, because I'm thinking I mean, obviously it's difficult and expensive getting a camera orbiting the Earth, but not that hard. You know, it can't be that difficult for companies to do it. So I know a few have given it a blast, but I want to show you this video here. This is a company called Space Exploration Network. I better make sure I've got that right. Anyway, look, let's just show you a couple of shots here. So this is a company that has put their own 4K cameras up in space. So that's much higher resolution than what we were talking about before, much more modern cameras, and they have just come back with some of their first images from space. So this is just looking at their satellite there, but have a look at some of this. Oh my goodness. Now, you're not seeing this at 4K, of course. I'm just broadcasting this at normal HD. But this is just a whole other step up. I mean, it's just absolutely incredible footage, some of it. It's just stunning. So there you go. Look, there's Italy. I mean, look at that. It's so beautiful. I just love it. It's amazing stuff. That's what I'm talking about. That's what I want to see. It's just, someone said about the world being flat. Hey, let's get back to that. We'll get back to that later on. No, the world's definitely not flat. So look at this, just amazing footage. So this is still just sort of the next step. This is not something that is available as an ongoing feed. They're just sort of testing and stuff. But you can go and look them up, SEN, pronounced SEN, for the space exploration. I keep thinking education, but it's the Space Exploration Network. And so hopefully we're going to be seeing a lot more from them, because that is just absolutely stunning footage. Oh, look, it's still going on. It's just amazing. It's incredible stuff. And I've seen it on 4K, on a big 4K monitor. Honestly, it's knee-trembling stuff. It's just absolutely incredible. Anyway, so that's that. Actually, look, while we're talking about nice footage, I'll just show you another quick clip here. Might just turn the audio down because we don't need the audio on this. This is from an upcoming BBC series, The Planets. I'm actually just going to squiz forward a little bit here. So this is obviously computer-generated stuff, and I just wanted to show you it because there is some really quite amazing footage in this. Unfortunately, I didn't get time to edit it and just pick out the best of it, sorry. So I'm just kind of letting it play. But I saw the most hilarious discussion of this online with, so this is all about the formation of the solar system. So there you go, whoever suggested that one. So this is talking about the formation of our solar system billions of years ago. And this thread on, I think it was YouTube, I can't remember, with all of these people discussing about whether this footage is fake or not, whether or not it's CGI. You think? You think it might be? So I don't know, honestly. I'm assuming that our audience all is just as amused by that as what I am, but goodness gracious me, people. Do you really think you need to argue about that? And I actually posted a comment saying I honestly don't know which people in this thread are serious, because you couldn't tell. You honestly couldn't tell which people were serious and which ones weren't. But anyway, look out for that. That's looking really neat. So looking forward to that series. Now I need to just catch up with where I am here. So we've talked about all of these things. I've mentioned that. Let's just do a couple of quick fire sort of headline type things, shall we? So let's just quickly talk about the poor old Chinese. This is only a very brief story, and that's because it was a failure. The Chinese tend to have very long, in-depth stories when they have a success. When something hasn't gone so well, it's just a very brief mention, if anything at all. So one of their recent launches, let me just look at my notes here. So this was probably a military reconnaissance satellite. But anyway, they had a problem with their Long March 4C rocket. I think it was the second stage didn't work. Yeah, second stage failure. So that's a bit of a downer for the Chinese, because that's the second problem that they've had with that launch. So although we've been talking about the Chinese a lot and talking about how well they're doing, they have got a potential little bit of an issue there. So we'll just see what happens in the future with that one. Here's another thing. Well, here's something you should definitely get on board with. Everyone needs to go and do this. You can send your name to Mars. So this is Mars 2020, the mission that we have been talking about that is launching next year. And you can sign up. The link is in the show notes. So you can sign up and get your name to Mars. You should definitely do it. We'll be doing it. In fact, we have done it before. So in fact, Floyd, I didn't warn you about this, but you know that we've been talking about the InSight mission on Mars. I'll get this is the Insight one, isn't it? Anyway, so you can sign up and get your name set there, and they send you a link where you can print out your little boarding pass, and it's all personalised and everything. So they've just got a little chip on there with your name on it, so you should definitely go and do that. Our family's signed up for a few different things now. We've got our name all over the solar system, so it's a lot of fun. All you guys out there in the audience definitely need to get on board, and remember to go and do that. Look in the show notes. The links there. It's a really neat thing that NASA's doing. They've actually got this whole system now where you sign up and you're in the system, so you can kind of keep a track of where your name is around the solar system. So yeah, that's a lot of fun. Definitely go and do that. What else have we got here? Going a little bit further out into the solar system. This is an article that was in Sky and Telescope magazine. And now, when you have a look down there at Jupiter's Great Red Spot. Now, this Great Red Spot, which of course is a big storm, just a bit bigger than the entire planet Earth, and it has been there for hundreds of years that we know of, but it's not permanent. It does change. And if you're familiar with the Great Red Spot, you can see on that photo there, it is actually changing. Where are we? Sort of around here, you can see it's been interacting with one of the atmospheric belts around there, and you can kind of see it spread out. So it is actually quite different. So yeah, it'll be interesting to see what happens with this. It's kind of been fading and changing a little bit lately. You can see it with a good backyard telescope on a good, decent night with good viewing. I think you need at least an 8-inch. I can see it with my 12-inch telescope on a good night. So it's definitely worth keeping an eye out for that one. See if you can see it yourself. It's one of those really cool things to see with your own eyes. But anyway, it'll be interesting to see what happens with the Great Red Spot in the months and years ahead. So that's that one. We've got another quick story here. We are celebrating the 100th anniversary, supposedly, of the confirmation of relativity. So when Einstein came out with his theories of relativity, he predicted, amongst other things, that light waves would be bent by strong gravity. And it was figured out that a way to test that would be during a solar eclipse. You'd be able to see the stars as they're getting near to the sun, and they would appear to be in a slightly different position relative to the other stars than they would normally, because the light rays would be being bent around the sun. Now, of course, you can't do that during the day, normally, because the sun's too bright. You can't see any stars. But during a solar eclipse, you can actually see them. So these are some of the plates from an expedition that went out and actually did have a look at that. And those lines there, sort of between the lines, is very hard to see, but that's actually a star in there, and you can see some of the others. And so this was actually seen as the big confirmation of Einstein's theory of relativity. And it was big news. This was kind of the thing that made it sort of official and gave him credibility, and was a very, very big deal in astronomy. Now, I don't know if anyone knows anything about this, but I recall seeing or reading some time ago that, in fact, the measurements that they made with this expedition were perhaps not quite accurate enough to really be considered confirmation. Of course, we have done since, but it was interesting that someone had mentioned that that was the case, but I've never seen anything else about it. So if anyone knows anything about that, I'd be interested to know. So was there anything else that we need to point out here? So yeah, it was astronomer Arthur Eddington verified Einstein's general theory of relativity, and you can see some more of the plates down there. So that's a kind of this day in history quick story there. What else do we have to talk about down here? How's our time going? Oh, we've still got a bit of time here. We might even get to talk about some of those suggestions yet. So let's talk about, what did I do with my comets thing? Oh, yucks, I think I might have lost my link to that. Never mind, I'll just talk about it. We've talked recently about that issue of water. I don't know if you remember, but it was discovered that some of the asteroids have been discovered with water similar to water on Earth. Speaking of which, I just need a very quick drink of water. That reminded me. Hang on a sec. So there's this question of, where did all the water on the Earth come from? So according to the general idea that we have of how the Earth formed. See, this was another suggestion, wasn't it? About someone talking about how the Earth formed. So I should be trying to respond to this. So I wonder if I can just bring up something over here while I think about this. So anyway, while I try and find that, the general idea is that the Earth was formed and it was all very hot and everything in the early days. Here's a couple of images that we probably can use to illustrate this. And it started off from this big cloud of dust and gas floating around in space. It looked something like this. So this is a very early solar system. There's a couple of other obviously computer-generated images here, just in case anyone's wondering. Over time, you can see things start clumping together and forming bigger and bigger things. Remember asteroid Bennu, which I think we might actually, yes, we will get back to asteroid Bennu as well. So all of these smaller things are clumping together and slowly forming bigger and bigger objects. But through this process, there's a bit of a mystery about where all the water came from. It didn't quite fit in, or it seems that the water must have come a little bit later on in the piece. So when Earth first formed, it didn't actually have all the water that we've got now. So where did all that water come from? Some time ago, it was generally thought that comets were the most likely explanation, but it turned out from studying comets that the kinds of water that you get on comet is different to what we have on Earth. Now, you might think that water's water. How can it be different? But it's to do with the hydrogen. So normal hydrogen just has one proton and one electron, but you can also get variations where you can have a neutron or even two neutrons in the nucleus of the hydrogen. So the ratios that you have of those different isotopes are sort of, I guess you could say, unique to Earth. We have a certain ratio with the water on Earth of those different isotopes of water, so water and heavy water. And it turns out that the comets we looked at had different ratios of water. So that kind of seemed to rule that out. However, recently they've been looking at some of these asteroids, and just in a news story we covered recently, it looks like the asteroids actually have the right kind of water, and they could account for perhaps about half of the water on Earth. So there you go, that's something. But it also turns out that now they've been studying a particular family of comets that also have the right kind of ratios of those isotopes. So it's starting to look more like we were actually possibly right in the first place, that it could have come from those comets. So there you go, that's just a little bit about the formation of the solar system. So there you go, we did get to talk about one of those things. So that's nice. I think that's probably all we need to say about that one. What else did we want to talk about? Oh, look, here's a random, completely different thing. If you've been to the Space Centre, you've probably picked up on the fact that I love Lego. Lego is just awesome. And we've got a big Lego display down the back there. And on the Lego website, you can go and vote for new things, new sets that Lego might put out. They haven't really done much about space for quite a long time, but they've got this one for the International Space Station that is a possibility. So I encourage you all to go to the link in the show notes. I think I've got it in the show notes. I hope it's there. Yes, Lego ISS proposal. Go and vote for this one, because I really want to have a new ISS Lego set. I think that would be very cool. So please go and do that. What else did we have up here? Now, the asteroid Bennu thing. Let's go back and talk about that. So we talked about this last week, and this was the one where NASA's mission OSIRIS-REx, it's a space probe that is around orbiting this asteroid at the moment. And I mentioned that the plan with this one was to keep orbiting around for now, but they're going to be looking for about a dozen different landing sites, different potential landing sites. And then I think by next year, 2020, I think they are actually looking at trying to get in there and take the sample from the surface of the asteroid. So interestingly, they are inviting you to help them figure out which are the best potential landing sites. So this is one of those citizen science projects where anyone can go and join up, link in the show notes. Now, it's not that straightforward. You find that most of these kind of citizen science projects, you do need to go through a sort of a tutorial series and learn what you need to do, but it is serious science, and this is genuine stuff. This is where you can be involved and get in there and genuinely help NASA out here. So if you want to do that, go and check out the link. And if you haven't checked out these beautiful photos, let's see if we can get a closer view of that one. It's not quite as close as the ones we were looking at last week, but just isn't that incredible? Actual surface of an asteroid. And that's what we were talking about before. So we're thinking that this is a really good example of the early solar system of everything starting to clump together, all the smaller bits coming together and forming bigger and bigger bits, and eventually something like this would end up being a planet. But of course this didn't make it that far, it's just an asteroid. So anyway, if you want to help out going to find the landing sites for NASA, go and give them a hand. Right, I know what else we wanted to talk about tonight, so we need to talk a little bit about Matariki. Now, if you haven't entered the competition, let's just quickly have a quick reminder about that. What we're looking for is just suggestions for things to chat about on the space show. So what you do is you type in topic, space, and what would be a good topic to talk about. Now, while I think about this, anyone in the audience who has not given Floyd your name, who wanted to enter the competition, could you just go and let Floyd know what your name is so that you're in the draw to win the competition there? Thanks. Everyone else, you've got about 5 minutes or so to get your entries in, so get stuck into it. Right, let me just quickly check my news links here. I don't think there's anything else that we desperately needed to talk about. Let's have a quick look at how the chats are going. So, Caitlin, you've done this. Is that the sending your name out into space? But we've got a few new people joining in with the chat tonight. That's looking really good. Welcome along, everyone. I don't have time to go through and talk to each one of you. Lisa, I think I responded to your message last week about how long it has been since the last moon landing. I think I misread your question there. I think you were actually asking, why has it been so long since the last moon landing? So look, just briefly, the short answer is money. It is a bit more complex than that, but really it's all about money. It's just so expensive getting to the moon, and really, who cares? Amongst the general population, it's not really a big issue. People don't hassle their politicians to spend more money to get back to the moon. It's not really a political thing. So yeah, I guess money is the short answer there. Right, so we've got about 10 minutes to go. So what I want to talk about is Matariki. Thank you very much for reminding me that. That is exactly what we need to talk about. So let's go and have a look at what is happening in the night sky. So this is the night sky as it is right now, if you go outside. So there's just a couple of things I want to mention here. Just before we talk about Matariki, hang on, let me just make sure that we are in the right space. Yeah, so if we, with our time selected down here, I think if we go forward to, this is the second, and let me just go forward to the early hours of the morning. No, we need it to be a day earlier than that. Here we go. So this is that makes it Sunday morning. Am I right about that? Yep, am I right about that? Thank you very much. So this is early in the morning, but actually we need to just go a little bit earlier. Well, it's no point trying to look for this when the sun's up. So let's just go back a little bit. So yeah, this is going to be a really hard one to see, but I wanted to mention it anyway. So we're just a little bit after 6 o'clock here, and you can see over there Venus and the moon very close together. However, if we zoom in, you will see that the moon is extremely difficult to see. It is in just the last stages of its crescent phase there before it heads into the new moon phase, so just sort of barely visible around there, but Venus just down there. So that's a conjunction with these two right next to each other. So if you're keen, you might want to get out and have a look at that. Now, you may, if you've got really keen eyes, have seen down there. What are we looking at there, everyone? What are we looking at? Do you see what we've got down there? It is Matariki, that's exactly right. So that is what we were going to be looking at. So I'll tell you what, first of all, before we do that, let's just come back to now, and we will need to head around to the west. If we just sort of zoom out a little bit. So this is looking towards the western sky right now. I'm just going to take the ground away. So you can see the sun down there is below the horizon. Of course, it's already set. And you may see down there, you can see Orion around there. And down there, very hard to see, but is indeed, that is sort of Matariki, very, is down here, so very close to the sun. But look at this, so you've got the sun there, and then Matariki is sort of ahead of it, right? It's going ahead of the sun here. Now, if we put the ground back, and we'll head back to tomorrow morning, and we will need to go around to the east, where all of that is going to come up. So, right, there we go. So the sun has already come up here. Let's just go back a bit. Now, so you can see the sun sort of coming up over there. And you can see that technically speaking, kind of, you can see Matariki over there coming up in the east. Now, so technically, it is actually rising before the sun. However, there's no chance of seeing that. It's just too close to the sun to be able to see it. So you can kind of see as we just go forward a little bit there, the sun comes up. So it's just before sunrise. So technically speaking, Matariki is rising right now. However, what we need to do is we really need to, let's just go back an hour. We need to just keep going forward one day at a time here. We can see Venus there, and you can see now we're sort of starting to get, say if we go halfway through June, you can start seeing Matariki come up there a little bit more before the sun. So each day it's coming up a little bit sooner before the sun. So we're going to be watching that over the next month or two, and then really sort of by about the end of June, you can start seeing it separate out a little bit more. And that's when we'll be coming back to have a closer look at it. Now, here in New Zealand, of course, Matariki has a lot of significance. We don't have time to talk about that right now, so it changes each year because the Maori calendar is based on the lunar cycle, not the solar cycle, so it's to do with the moon going around the earth. It does actually change each year when Matariki is actually celebrated here in New Zealand. Now, there are various different stories around New Zealand about exactly when we should be celebrating Matariki. My go-to guy with any stuff to do with this is Dr. Rangi Matamua, who is a professor at the University of Waikato. So when he says something about this, I think you can trust him. He's the guy to go and look, and if he says something, then that's the real deal. So we will be talking more about Matariki as the time comes closer to it. In the meantime, if you want to know, whoops, this isn't what we were supposed to be looking at. I wanted to look at this website. If you want to know what's happening, well, around the Waikato here, where we are based, there is a website. You can see the URL up there. I think I've got the link in the show notes. But all around the country, there will be other websites showing you what sort of things are going on to celebrate the festival. So this year, the period of celebration for July is sort of generally sort of between the 14th of June and the 28th of July. So for example, here in the Waikato, we've got there's a whole program here that you can go and have a look at, and these are all the various things that are happening. Now, we are doing something at the Space Centre. Unfortunately, they haven't updated this for a little while here, so our day's not showing up here yet, which is a bit of a shame, but we will be doing a Matariki themed day here at the Space Centre on Sunday, June the 30th. It is one of our normal open days, but we're going to be having Matariki stuff happening all day there. So if you're interested, come along and be part of that. Or just have a look around and see what else is going on near to you. So that is pretty much all we're going to talk about Matariki tonight. However, we probably will come back and cover it as it gets closer to the time. So we are getting very near the end of our show tonight. Do we have any questions or comments out there in the audience that anyone wants to contribute? In that case, Floydie, how are we looking with the... You need to write a few more names? Okay then, so while you do that, why don't we go back and have a look at the chat. I will just have another quick drink of water while we do this. Let's just randomly pick a topic. So, okay, thank you for that comment, Scott. Here's a topic, the first one I see. How much does the moon affect us on Earth? So that was from Janet, thanks for that, Janet. A lot, it affects us a lot. So, one of the things that the moon does is it helps keep the Earth stable. So the Earth doesn't really wobble around a lot like this. It does, but not a lot. It basically, as it rotates, as it orbits around the sun, it rotates around like this in a pretty stable sort of fashion, and the moon helps it to keep it like that. If the moon wasn't there, or if the moon did something very funny, we would find that we are wobbling around a lot more, and that would not be such a good thing. Obviously, one of the big things about the moon is the light. So on a full moon night, you can go outside and you can walk around and you can move around. So a lot of life here on Earth is affected by the moon. Quite seriously, actually, it's a big part of a lot of life cycles with animals here on Earth. Tides, obviously, the moon affects the tides here on Earth. So that's an interesting thing that people often struggle with, the tides, because of course you've got the Earth here and you've got the moon a long way out actually, but let's say the moon's out about here. People often struggle with getting their head around exactly how the tide works. So the moon and the Earth are both pulling on each other, of course. They've got their own gravity. So people get the first part of it right most of the time. So you imagine all the water here on the Earth and you've got the moon out here and it's pulling the water towards the moon. Okay, that's pretty straightforward. That's a high tide, right? It's pulling the water up, and so it spreads out over the land a little bit. That's a high tide. However, there's also a high tide on the other side of the Earth at the same time. So how does that work? It's kind of a weird thing, isn't it? Does anyone want to have a stab at it in the audience? Does anyone want to talk about it? Okay, yeah, it's yeah. Sorry, I'm putting you on the spot there, but think of it like this: the moon is pulling on everything over there. So gravity, it goes down a lot. Its effect goes down a lot as you get further away from it, of course. So just imagine that the Earth is pulling on three different things here. We'll think about it like that. Three different things that the moon is pulling on. It's pulling on the oceans on this side, and it's pulling on that the most. It's pulling that towards the moon. Then it's pulling on the Earth itself. Last of all, it's pulling on the other side of the Earth, on the ocean over there. So that's kind of getting left behind. So it's pulling everything towards it, and the tide on that side is left behind. It's not being pulled, it's being left. So it's kind of pulling it that way. Does that make sense to you guys out there? Okay, yeah, kind of, okay. So that's how the high tides work. By the way, just in case you didn't know about it, it is pulling all that stuff. The high tide doesn't just affect the oceans, it affects the ground as well. So all the land is actually being pulled up as well. So I believe that on a typical land mass around here, we are actually rising and falling about 30 centimetres every day. So we're all affected by the tide. It's not just the water. There you go. Floyd, are you still going down there, are you? Yeah. Okay, still going. You're working really hard. Good on you, buddy. Let's see if we can... I think that was all I was going to say about the moon. What's the next one? If we just go... do we see more stars here in NZ than other places in the world? Oh, so I'm Janet. That's a bit unfair, isn't it? I'm both from you. Do we see more stars? That's a good question. I don't know that we would see more stars. We definitely see different stars. So let's just quickly go over that. So just as I was saying before, the Earth is rotating around like this as we orbit around the sun. Now, as it goes around the sun like that, just the people on the northern hemisphere up here, they can see all the stars up there, and to some degree all the stars around here. They can't see the stars right down there because you'd have to be looking straight through the Earth. And as I said before, the Earth doesn't wobble around like this. It keeps spinning around like this. So the North Star, straight up there, we never see that from down here. Likewise, the Southern Cross, which is down there, the people up here will never see it down there. So we can see the stars sort of out the side there. You can see that just about anywhere on Earth, but we each do get to see different sets of stars. So the Southern Cross is definitely a southern hemisphere. It's quite near the South Celestial Pole. We talked about that a few weeks ago. Matariki is a little bit different. Matariki is out the side, effectively, so it can be seen from most places on the Earth. So that's why cultures all around the Earth have their own Matariki stories, their own names for Matariki, their own stories, and it's used as a seasonal marker all around the Earth. As it is here in New Zealand, we use it as a marker pretty much for the winter solstice, but in different parts of the world, in different places, they use it as seasonal markers for different parts of the year. So I think that kind of answers that question. We're looking good, are we, Floydie? So I think we'll go with that. Floyd's got all of the entries in the space helmet over there. So what we need is someone from the audience to pick out a name from the helmet. We should probably choose someone who has not entered the competition, really, to try and keep it fair. We had a little bit of a scandal here a few weeks ago, didn't we? Where, yeah, in the background there, that's my mum looking very sheepish. We had a scandal when the prize was drawn and it turned out to be my mum was the winner. So we're not going to do that again. Anyway, who wants to... okay, thank you very much. So come over here. So you just draw a name out and see if you can call it out.
Oh no, that's her name.
You are kidding me.
I switched them around.
Bring it here and show me, Floyd. Bring it here. Yeah. It is indeed Vienna. Oh my goodness. Okay, so it's scandal time again. Oh goodness me. Look, anyway, while you guys are there, I just want to point out, we talked about Wendy and Vienna last week. So Vienna, just put your hand up there so we can see who you are. Vienna was the one that we talked about last week, who's donating some of her own money to our Patreon fund. So thank you very much, Vienna. Here is your reward. You get... I didn't tell you what the prize was, did I? I'm just shocking with this. At least I did remember to organise a prize tonight, but I completely forgot to tell you what it is. And I hold all you people out there responsible because it's supposed to be your job to tell me what I'm not doing right, okay? And you people at home. Anyway, look, the prize was this beautiful little set of crystals here. Really nice little crystal box. So there you go. Vienna, do you want to come and get your prize? So, congratulations, well done. I hope you enjoy that. So, good on you. Thanks, Vienna. Okay, so I think that is about it for tonight, really. Look, one last quick thing I'll just quickly mention. This is science fiction, actually. There's some new trailers that have just come out. I'm not going to play them to you, but I saw the trailer for Terminator. I didn't even know there was a new Terminator movie coming, and it's got Linda Hamilton in it, actually. I had no idea this one was coming. So Terminator Dark Fate, go and look that up if you want to. If you're into Westworld, there's a trailer out for season 3 of Westworld. And perhaps my favourite amongst this is Star Trek Picard is coming out. Hey, anyone else into that? Anyone else looking forward to Star Trek Picard? Yeah, that's going to be a good. I hope it's going to be a goodie. And I don't think Patrick Stewart would have gone into this if he didn't have some faith in this one. So I'm hoping that's going to be a good one. In other Star Trek news, I think, someone correct me if I'm wrong, but I think the whole, the movie with the Kelvin timeline, you know, the rebooted one, I think that's dead and buried. I don't think they're making any more, so I'm not 100% sure about that. But anyway, those are just a couple of quick asides there. So let's just have one last little look at the chat. Esther, you're with me on that one. I'm sure you'll be into the Picard thing. So look, thank you all so much. While I think about, while we're looking at the comments here, that worked quite well last week. I mentioned that because I don't really get time to go through every single comment and we're getting more each week, I am going to go back after each show and try and answer a lot of these questions. So sorry, really sorry if we didn't get to your stuff during the show, but do check back in a couple of days and see if I've got round to doing something about it then. So I think that is about all we're all happy?
There was a question, is Subaru the name, the Japanese name for Matariki?
Is Subaru the Japanese name for Matariki? Okay, so let's finish off with that, shall we? So let's just look over here. So this is various names for Matariki around the world. You can see some of them utterly unpronounceable. Matariki down here in New Zealand, of course, and you can see up there, indeed, Subaru is the name, the Japanese name for Matariki. And if you have not noticed, which you should have done, but if you have not noticed, that is the logo. Check it out. That is Matariki. Now, they only have 6, don't they? 1, 2, 3, 4, 5, 6. Yeah, they only have 6 stars in their logo there, but that is indeed Matariki that you are looking at there. So, who asked that question?
Somebody on your feed.
Oh, someone on the feed. Oh, okay, sorry. So it was in the chats down there. So, sorry, I missed that. Anyway, right, look, thank you for everyone. Bob, nice to see you in tonight. Thank you for that. Thank you for all those comments. And I think, as I say, we'll go back there and I will check them all out and try my best to answer them. So look, if you've got any more comments and questions for the show, we would love to hear that. If you want to get on board and help us out with our Patreon, I've actually put the link in the descriptions this time so that you can get there and go and send us some money. We really do appreciate that because it does cost us to do this. And so, yeah, we're always keen on more money. So I think with that, we will wrap it up and say a very good night to you all, and we'll see you back here again same time next week. Good night.